Hi, today we are looking at section 6.2, which is characteristics of equations of polynomial functions. So we looked at some example graphs of polynomial functions in the previous section and talked about degrees and how many times they turn and our number of x-intercepts. Today we're going to look at some more characteristics about them. So different functions in general form, just as a reminder, linear, we typically write as y equals mx plus b. That could also be written as y equals ax plus b, where m cannot equal 0. Quadratics are written as y equals ax squared plus bx plus c, where a cannot equal 0. And cubic functions, y equals ax cubed plus bx squared plus cx plus d, where a cannot equal 0. Now, once again, if you remember, our largest exponent is our degree. So our linear function would be degree 1, quadratic degree 2, cubic is degree 3. So once again, degree of a function refers to the largest exponent in the function. Now with polynomials in standard form, the maximum number of x-intercepts is equal to the degree of the function. So if we have degree 1, we can have up to 1 x-intercept. If we have degree 2, we can have up to 2 x-intercepts. Degree 3, we can have up to 3 x-intercepts. Now our maximum amount of turning points is 1 less than the degree. So for example, a linear function would be degree 1. If we subtract 1, that's 0, so it does not have any turning points, which makes sense because it's a straight line. A quadratic's degree 2. If we subtract 1 from that, we get 1 turning point, which would be our vertex. Now, our degree and the leading coefficient determine the start and end behavior of our graph. And our constant term indicates the value of our y-intercept. For linear and cubic functions, if the leading coefficient is positive, the graph will begin in quadrant 3 and end in quadrant 1. If the leading coefficient is negative, the graph will begin in quadrant 2 and end in quadrant 4. For quadratic functions, if the leading coefficient is positive, the graph will start in quadrant 2 and end in quadrant 1. If the leading coefficient is negative, the graph will start in quadrant 3 and end in quadrant 4. Okay, for each equation, determine the degree, the leading coefficient, constant term, and the end behavior. Okay, so first thing we want is the degree. So the degree of A would just be this exponent here. So that would be degree 3. Degree of B, technically, if we don't have an exponent, it's to the power 1, so our degree would be 1. Then for C, our degree is 2. And for 4, our degree is 3. It doesn't have to be our first term in our function. It just has to be on the largest exponent, so it would be degree 3. Now, leading coefficient, I'm just going to abbreviate with LC. So our leading coefficient for this first one would be positive 3. Our leading coefficient for this one here would be our negative 5. Our leading coefficient for this one would be 4. And then our leading coefficient. For this one, we have to look at our term with our largest exponent, so that'd be this term, so our leading coefficient would be -5. I'll call my constant term CT, just to abbreviate. So constant term for this first one is just going to be 10. Our constant term for the second one is 12. Constant term for this last one, for this one is -12. And for our last one, we don't have a constant term listed here. So that really means that's the same as +0. So our constant term would be 0. Now our end behavior. So this is an odd degree cubic function. It is a positive leading coefficient. That means it's going to start in Q3 and end in Q1. Next one, we have a linear, so that's odd degree, and a negative coefficient, so that means it's going to start in Q2 and end in Q4. Next one, we have even degree. It's a quadratic. We have a positive coefficient, so it's going to start in Q2 and end in Q1. This next one, we have a quadratic that's negative leading coefficient, so that is going to start in Q2 and end in Q4. Okay, for following graphs, identify the degree, sign of our leading coefficient, and the constant term. So we can see this has two places where it turns around. So our degree is one higher than that. So we have a degree of 3, positive leading coefficient, because we're starting down here and ending up here for a cubic. And our constant term is right here. So our constant term is 2. Next one, we have one turn, so that means our degree is one more than that. So we've got degree 2. Now it's a quadratic, it's opening downward, so it's starting in Q3, ending in Q4, so that means it's a negative leading coefficient. And our constant term is where it intersects here. So 1, 2, 3, 4. So our constant is equal to 4. Okay, so we have a straight line here, so no turns. So therefore, that would be a degree 1. Now, because it's a degree 1 or linear and it's starting here, ending down here, that means it has a negative leading coefficient. And we have a constant of -3. Okay, so last one. This one, we've got two places it turns, so our degree would be one more than that. So we've got a degree 3, which is a cubic function. Now, because it's a cubic and it's starting here, ending here, that means it's a negative leading coefficient. And we have a constant of 7.